Hello students, today let's we talk about the atmospheric refraction. So you might have observed the apparent random wavering or flickering of objects seen through a turbulent stream of hot air rising above a fire or a radiator. So above this object you might see that the wind or air are flickering or wavering because the air above these objects are very hot and hot air generally light in weight. So that is the phenomenon you might observe, the flickering and wavering of the air above this object. The air just above the fire become hotter than the air further up, right? Obviously the air just above the fire will be hotter as compared to the air above it. So the hotter air is lighter, it means less dense than the cooler air above it, and has a refractive index slightly less than that of the cooler air. So here what happened, the cooler air is heavier and the hotter air is lighter in weight. So we can say that hotter air is less dense while cooler air is more dense. So because of this density difference, the refractive index is also going to be slightly changed of hot air and cool air, right? So since the physical conditions of the refracting medium, that air, are not stationary, the apparent position of the object as seen through the hot air fluctuates, right? So that is the reason that composition of air in the atmosphere is not equal, or that is the reason that object that we are going to see through the air, the position of that object may be fluctuate. So this wavering is thus an effect of atmospheric refraction on a small scale in our local environment, right? So the twinkling of star is a similar phenomenon on a much larger scale. So we see that during a night time we can see that stars are twinkling. So actually they are twinkling or not, and if not, then why we are seeing that stars are twinkling? So that is because of the atmospheric refraction. So let's see the twinkling of star. The twinkling of a star is due to atmospheric refraction of starlight. The starlight on entering the Earth's atmosphere undergoes refraction continuously because air composition will not going to be uniform throughout. So because of that reason, what happened, the starlight which entering the Earth's atmosphere will undergoes the refraction continuously before it reaches the Earth. So the atmospheric refraction occur in a medium of gradually changing refractive index. So अगर atmospheric refraction होता रहेगा continuously, then what happen? It will change the refractive index of that starlight, and because of that change in refractive index, what happen? The atmosphere bends starlights towards the normal, and the apparent position of the star is slightly different from its actual position. So here you can see the figure that actual position of star is here, and this will be its apparent position due to the atmospheric refraction. So due to the fluctuations of the star position, we feel like star is twinkling, right? Okay, so the star appears slightly higher than its actual position when viewed near the horizon, as you can see in the figure. Further, this apparent position of the star is not stationary but keeps on changing slightly, since the physical conditions of the Earth's atmosphere are not stationary, as was the case in the previous paragraph. So since the stars are very distant, they approximate point-sized source of light, and as the path of rays of light coming from the stars goes on varying slightly, and that is the reason we can see the apparent star position, and that apparent star position which we are observed through the horizon, it is also not stationary. It will also going to be fluctuate as per the refraction of the light, and as if the position of any lightning object is going to be fluctuate, then it will like a twinkling, right? And that is the reason that we are observing that stars are twinkling while we are observing it, right? Because of the atmospheric refraction. Now let's we see the next other phenomenon due to the atmospheric refraction is advanced sunrise and delay sunset, right? So basically the sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset because of atmospheric refraction. इसका मतलब ये हुआ कि सन राइज हो उससे पहले 2 मिनट पहले ही हमको दिखता है एंड सनसेट होने के बाद भी 2 मिनट तक हमको सन दिखता है. सो व्हाट इज़ द रीज़न बिहाइंड इट? द रीज़न बिहाइंड इट इज़ द एटमॉस्फेरिक रिफ्रैक्शन. So let's we try to understand it. By actual sunrise we mean the actual crossing of the horizon by the sun. See, if the sun will cross this horizon, then only the sun will visible to us, otherwise not, right? So actual sunrise means what? That the sun will going to cross this horizon and then we are able to observe the sun. But what happened? The actual and apparent positions of the sun with respect to the horizon and the time difference between actual sunset and the apparent sunset is about 2 minutes, and the apparent flattening of the sun's disk at sunrise and sunset is also due to the same phenomenon. So here you can see that sun right now is below the horizon, right? But due to the atmospheric refraction, what happened? You will not see the original position of the sun, but you will going to observe the apparent position of the sun. And here you can see the apparent position of the sun is above the horizon, and that is the reason still the sun is not rised, but still you can observe the sunrise because of its apparent position due to the atmospheric refraction. And same thing will happen when the sun will going to be set down, right? So sunset means what? Sun will goes below the horizon line. So though the sun will goes below the horizon line, due to the atmospheric reflection, his apparent position will still able to observable, right? And that is for 2 minutes, right? तो 2 मिनट सनराइज अर्ली होता है, 2 मिनट सनसेट लेट होता है. एंड ऑन द बेसिस ऑफ दैट इफ़ यू आर ऑब्जर्विंग द होल डे, then it would be 24 hours 4 minutes, right? So advanced sunrise and delayed sunset is because of the atmospheric refraction.